ground ring can offer several benefits when installed around a general office building. Firstly, it helps reduce earth potential rise. A ground ring lowers the electrical potential difference between the ground and the building. This reduces the risk of dangerous ground faults and equipment damage during lightning strikes. Secondly, improved surge protection is another benefit. A ground ring provides a low resistance path for lightning surges to travel. This dissipates them into the earth, minimizing their impact on sensitive electronic equipment. Thirdly, it can provide enhanced grounding system reliability. Multiple grounding electrodes connected by a ground ring create a robust and redundant grounding system, ensuring a reliable connection to earth. Concrete-encased electrodes are an alternative to ground rings. They offer several advantages, including lower cost, because concrete-encased electrodes are typically less expensive to install than a ground ring. Another advantage is easier installation because they can be installed quickly and easily compared to the extensive trenching required for a ground ring. They are also less disruptive, because the installation of concrete-encased electrodes is less disruptive to building operations than digging a trench for a ground ring. However, a ground ring provides better overall protection than concrete-encased electrodes due to its ability to, firstly, create a more uniform grounding potential around the building, secondly, reduce ground loops and interference, and thirdly, provide a continuous path for lightning surges to flow. The minimum size of a ground ring is determined by several factors. These include soil resistivity, building size, lightning risk, and applicable codes. As a general guideline, for a 300-foot by 75-foot general office building with moderate lightning risk, consider the following. For the conductor size, use 1/0 American wire gauge bare copper. The trench depth should be 12 to 18 inches. The trench width should be 12 inches. The spacing between electrodes should be 20 to 30 feet. Note that specific requirements should be determined by a qualified electrical engineer based on site-specific conditions and applicable codes.